Okay, third of 4 videos on structural change, and now it's a model with basically pure income effects. And then we're going to compare the two models in their ability to explain what's actually going on. But for now, it's the models. Okay, so what does the income effect model look like? Let's take a look. So we've got household, firm, and energy sector. And we've got labor. This one is explicitly general equilibrium. We've got labor, LR and LY. And we've got R is phi A LR. Okay, so A here is an overall labor productivity, isn't it? LR is the actual labor input. LY labor input here. And what do we get out? There are multiple products. Okay. And there can be any number of products in this model, which is kind of nice. And they're indexed. So it's not a continuum of products. There's like product 1, product 2, product 3, and so on. And the production function for product 1 is Y1 is A times the minimum of Ly alpha R. The production function for product 2 is Y equals A over 2 times the minimum of Ly alpha R over 2. And Y3 is A over 4 times the minimum, blah, blah, blah. So what about Yi? Maybe you should have a think about that. Pause the video. What's the production function for Yi? So when I is 2, it's A over 2. When I is 3, it's A over 4. So it's A over 2 to the I minus 1, isn't it? Yep. When I is 1, it's 2 to the naught. That's just 1. When I is 2, it's 2 to the power of 1, 2. When I is 3, it's 2 squared, 4. When I is 4, it's going to be 8, and so on. So that's the overall productivity. So what's that telling us? It's telling us that these goods are getting increasingly expensive. Yeah, they're trickier and trickier to make as I gets bigger. They're more and more expensive to make. So far, that's what we can see here. Then there's maybe something else going on in the rest to compensate. We'll see. So then we've got times the minimum of 2 inputs. So we've got a Leontief production function, haven't we? And one of the inputs is just Ly. So it's looking very much as if these products are indeed getting more and more expensive as we go down. Because there's no pre-multiplier of A with 2 to the I, which is getting bigger while this is getting smaller. So I've realized I'm running out of space. I'm going to shift this whole thing across. So we got Yi equals A over 2 to the I minus 1 times the minimum of Ly and something else. A alpha, I think, times R over 1, 2, 4. It's the same thing, isn't it? Alpha R over 2 to the I minus 1. So what's that telling us? It's telling us that for product 1, for each unit of Ly, we need alpha units of R. Sorry, 1 over alpha units of R. But for product 1. But for product 2, for each unit of labor, we need alpha R. We need over here, we need, if this is 1, this has to be 1. So alpha R over 2 has to be equal to 1 for product 2, doesn't it? So alpha R over 2 equals 1. Alpha R equals 2. R is 2 over alpha. For product 3, R needs to be 4 over alpha. For product 4, it's going to be 8 over alpha. We need more and more R as we go down. So these products, the successive products, they're getting more and more expensive and more resource intensive or energy intensive. Okay. That's what we can see there. Now then, what else can we say? We've got LYI over LRI is something. Okay, so how are we going to work that out? Okay, so it seems like I should have had a Y. I should have had I's here, shouldn't I? To be consistent in my notation. Yeah. Yeah. Okay, so that's better notation now. Okay, so these are always equal, aren't they? So LYI equals alpha RI over 2 to the I minus 1. Yeah, if these aren't equal, you're just throwing stuff away. It's like you always want an equal number of left shoes and right shoes. You wouldn't ever buy 4 left shoes and 1 right shoe. You'd just be wasting your money on 3 of the left shoes, right? In the same way, the firms are always going to buy inputs such that these are equal. Okay, so, but RI is phi A LRI, isn't it? Alpha phi A LRI, where LRI is like the amount of this labor that is working to produce the R that is used by firm to make product I. Okay, it's the sort of labor here which is attributable to the specific product I. So that should be our expression. If we bring this down, we've got LYI over LRI is alpha phi A over 2 to the I minus 1. Alpha phi A divided by 2 to the I minus 1. Oh, yes. Okay, that was correct on the notes. So finally, what is RI over L? Shouldn't that be LI, I think? It should be RI over LI. Maybe I'll change that by the time you see this. Oh no, you're seeing it now, aren't you? Whatever. My guess is that should be LI, which is the sum of LRI and LYI. Let's see. So, so I'm getting tired here. I'm going to pause this and just think through what I need to do to get this result. Okay, I think I can see what to do here. So Ri is phi A Lri. Li is Lyi plus Lri, which is Lri times 1, that's the Lri, and now we want Lyi, but Lyi is Lri times this. Lri times this. Alpha phi A over 2 to the I minus 1. And then the LRIs are going to go out, aren't they? So that goes out with that. And we have this. And I'm just going to rewrite it. I'm going to shift that phi A like that. And hopefully that is the expression in the notes. Let's have a look. Phi A over 1 plus alpha phi A over 2 to the I minus 1. Yeah, and we don't need these brackets anymore. Okay. And yeah, we should have that I subscript. So where is this getting us? But yeah, I never really gave a background to this, but because the idea is here, we've got a series of products. The more expensive ones are more energy intensive. And then we're going to add a preference function, which says that as we get richer, we shift into the more expensive products. And then, of course, that will give us this income-driven increase in energy intensity of the products. So what have we got? We say that WL, the wage, is just A. And GDP is WLL. Okay? Or AL. Then we say preferences are lexicographic. You choose the highest A you can afford, subject to a restriction that CI must be higher than C bar. So this is C, your consumption. And you're going to choose the highest I you can afford, subject to a minimum quantity of the good. So you basically, it's like this, if you think of these goods as all different foods, you want to buy the fanciest food you can afford, subject to the restriction that you want enough to eat. Yeah, so as you get richer, you don't eat more, you eat better food. Or more exactly in terms of the model, as you get richer, you don't consume more and more of the same stuff. You want to maintain the quantity of your consumption, but you shift to more and more luxurious, energy intensive goods. And if we define then AI bar as the minimum A such that good I is affordable, then we can work out the following expression for AI bar. And I'm not going to go through it. Okay. So what do we get? We get that AI bar is 2 to the I minus 2 times the square bracketed thing times C bar. And what's the square bracketed thing? It's 1 plus 1 plus 4 over alpha phi C bar. to the half, or the square root of that. Okay. So that's the result. I'm just going to pause and think exactly what I want to say about this. Okay, so I've been totally focused on the math here. But now I've flicked back to the previous slide because now I just want to talk you through what does this all mean. Okay. And it's kind of cool. It's a bit tricky, but it's kind of cool. So what's this? This is a bunch of parameters, isn't it? All this stuff is given. This is the minimum level of productivity needed for us to be able to afford good I. So let's assume that A is at a level such that we can afford the fifth good. Okay, and it's exactly that level. We're on the borderline. Okay. So I is 5, and we can exactly afford that fifth good. Then assume that A doubles. What good can we afford now? We can afford the sixth good, can't we? Because the level of A we need to afford the sixth good is twice as big as the level of A we need to afford the fifth good, because we've added 1 to this power. Everything else has stayed the same. So this whole thing, when I goes up by 1, this whole right-hand side doubles. We need twice the productivity. So basically, every time productivity doubles, we shift up a good. Okay, in terms of energy intensity and cost of the good. What else happens every time productivity doubles? GDP doubles, yeah? Because GDP is A times L. So productivity doubles, GDP doubles, we move one step up the ladder on the goods. What happens to this? Li, we're only ever consuming one good at a time. So Li and L are the same thing. Total labor. And actually Ri and R are the same thing too. So R over L, what happens to R over L when A doubles and I goes up by 1? This has doubled, this has doubled. So this stays the same, but this has doubled. So the right-hand side here doubles, R over L doubles, R doubles. Okay. So productivity doubled, shifted up one good. GDP doubled because the good is twice as valuable. Resource use doubled because the good is twice as energy intensive. Right, and that's it basically. If we didn't have these shifts, if for some reason we stayed on the same level of I as A went up and just consumed more, then R would not rise. R over Ly would stay the same, wouldn't it? It would be alpha over whatever this value is, depending on which value of I we stick at. So it's purely due to the shift in the products that R increases. Yeah. If we didn't shift products, R would stay the same compared to L. Okie doke. What happens in this economy if we raise alpha? Oh, that's an interesting one. But if we raise alpha, whoa, we'll save that for a study question. I'm getting exhausted here. Yeah, let's leave that for a study question. What about rebound? Let's leave that for the study questions as well. I'll just read through this blurb and see if I want to say anything. Rebound occurs when, for instance, a 10% increase in energy efficiency does not give a 10% decrease in energy use. Okay, you got the answer here. That's a shame. In the above economy, there's almost no rebound. The reason is that increases in energy demand are driven entirely by income effects. What happens in this economy if we tax energy use? Okay, so the whole discussion of that slide, I'm going to leave to the Zoom session. So there's plenty to think about there. Okay, and that is the end of this video. Then we've got the fourth and final one to come.